Hey everybody, welcome to CPM 3. We are going over Module 3, Lesson 2, which is Factoring Trinomials. Basically what we're doing today is the opposite of what we did in Lesson 1. In Lesson 1, we were given two binomials, and then we would FOIL, right? We would do the first, the outer, the inner, the last, and then we would get our answers x squared plus 4x plus 3 once we combined it like terms. Now I'm going the opposite way. Now we're going to be given this x squared plus 4x plus 3, and I need to factor it into its two binomials. So in order to do that, we have this little factoring trinomials in the form. Our form will always be with this x squared. The other form of trinomials is ax squared plus bx plus c, where basically you have a coefficient in front of that x squared term. So for example, maybe something like 4x squared plus 6x plus 10. All of ours are going to be in the form where we have no coefficient. So for example, like this one here, where you just have that x squared, you just have x squared, just have x squared, and in this case you just have r squared. So we have no coefficient in the very front. And when this is the case, which it will be the case for all of ours, you want to try and find two things. When you factor this, when you have your two binomials, you always have the first term in both of these is your x. That way, when you FOIL and you do your first, x times x gets you to that x squared. So then you have to figure out what are these two numbers that are going to go in the very back. And you want it to meet two criteria. The first criteria you want it to meet is that these numbers have to be the product of c. Okay, so you want it to multiply to whatever your c term is. And then the second thing you want is for the sum of these numbers to add up to b. And so it's got to meet both of them, not just one or the other. And so the way we will be doing this is we'll make a little x. We're technically going to put our a times c up at the top, and whatever a is always going to be 1. Okay, but our a times c, and then our b term down here. And we're going to find two numbers that add up to b, but multiply to our ac. Okay, and then those two numbers will go right here. So, for example, example 1 says to factor x squared plus 7x plus 10. So before we even start this, let's just make sure we understand what I mean by a, b, and c. Your a, b, and c is always in order. So your a is 1, since we have a coefficient of 1 right here. Okay, it's not the x squared, it's not the x, it's not whatever the variable is, it's the coefficient, the number. So then your b term is going to be this 7. And then your c term is this very last one. It's your constant. That's your 10. And so as long as it's x squared x, no x, it's always in order of a, b, c. Okay, so now that I know my a, b, and c, let's go into our x. And I'm going to rewrite this so I have a little bit more room. Okay, we said a is 1, b is 7, c is 10. Okay, so now go into our x here. So in my x, my a times c goes up here. So in this case, my a times c is 1 times 10, so it is just 10. And really, it's always going to be your c, because our a is always going to be 1. My b term goes down here. My b is 7. So now I need to find two numbers that when I add these two numbers together, we get 7. But when I multiply those two numbers, I get 10. So think of your multiplication. What can you multiply to 10? And then those add up to 7. Well, 1 times 10 multiplies to 10. But when I add 1 and 10, that gives me 11. But 2 and 5 do work. 2 times 5 is 10. 2 plus 5 is 7. So these are my two numbers. So now when I factor this, you're always going to have x at the beginning, but what we found were these two numbers that go in the back. So this will factor to be x plus 2 and then x plus 5. So that is my final answer. And this is the only one I'm going to do this with, but you can check all of your answers. If I kind of come over here and FOIL these, we've got x times x, that's my first, that's x squared. My outer, x times 5. My inner, and then my last. And then when we combined our like terms here, my final answer is x squared plus 7x plus 10. So when I FOIL, I get back to my original, so I know I have factored that right. So all of these you can check. And just so you guys are aware, it does not matter how you write this. So notice that I did 2 and 5, right? X plus 2, x plus 5. If you switch it and you do x plus 5, x plus 2, that is the exact same thing. Okay, so it doesn't matter the order that those numbers go in, as long as it is 5 and 2 or 2 and 5, it doesn't matter the order there. Now, I am going to go over and go through most of this lesson using this X method here. But I will say this X method, it only works for people that are good at their multiplication tables. So if you are not good at your multiplication tables, when we turn this page, I'm going to do the first 5 here using a different method. If you like that method, you can use it throughout the whole thing. But after I do these 5, I'm going back to that X method because it is quicker. But it is not good if you're not good at multiplication. So, here's the second way to do this. Okay, if you don't like that X, what you can also do is kind of make a chart. I know that this is my C, and I know I want two numbers that are going to multiply to 12. Okay, multiply to 12. I need to look for something that multiplies to 12 but then adds up to this middle term to that 7. So, always start with 1. 1 and 12. Okay, 1 times 12 does meet the criteria of multiplying to 12, but when I add them up, we get 13. So go down to the next one. I know I can divide in, or I know 2 is a multiple of 12. So 2 times 6 gets me to 12. When I add these two together, we get 8, not 7. So go down to the next one. We can divide in a 3. So 3 times 4 is 12. When I add these together, do we get to that 7? Yes, we do. Okay, so now that I have my numbers that meet both criteria that multiply to 12 and add up to 7, we can factor these to x plus 3 and x plus 4. So we start with 1, then just go to 2, go to 3, go to 4. If it doesn't go into that number, skip a number. Okay. Now, both of our examples so far have been plus plus. So when it's plus plus, that means both of my numbers are going to be positive. I probably should have reconstructed this lesson a little bit differently, but if you turn the page here, it kind of shows you the patterns. So if you have the same sign here and both of these are positive, that means you have to have positive, positive. Now the other thing that can happen is if you have a positive number for C, another way to get to that positive number is to times a negative times a negative, right? Negative times negative is positive. So if this is positive back here, but then this one's negative, instead of it being plus plus, now it is minus minus. So now negative 2 times negative 8 is positive 16. But when I add them together, negative 2 plus negative 8 gets me to that negative 10. Okay, so you kind of want to look at the signs to see what are your signs going to be. And then if you have a negative for that C, the only way to get to a negative number is to multiply a positive times a negative or a negative times a positive. So it means your signs are going to be different. So then you have to choose which one's going to be positive. If this one's a positive, then that means your bigger number has to be positive. So now positive 8 times a negative 2 is negative 16, but 8 minus 2 is a positive 6. Now if it's the same thing, but a negative 6 here, now you need that bigger number to be negative. So now negative 8 times 2 is still negative 16. But when I add them together, negative 8 plus 2, now I get that negative 6. Okay, so you kind of want to look at those signs to see, you know, what your signs are going to be. So, kind of using that information here, look at this. On this one, my C is 35. Okay, so we need something to multiply to a positive 35. But when I add them, we get to a negative 12. So because this is positive, it means we need the same sign. So either positive, positive, or negative, negative. But because this one is negative, we need two negatives. So when I go through my multiples, instead of having positive, 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 we're going to have all negatives. So go through your multiples of 35. Always start with 1. So that means negative 1 and negative 35. When I add those together, do I get to a negative 12? Well, no, that's negative 35. So keep going down the list. Can we divide in a 2? We cannot, so we're not going to write it down. Go to the next one. Can we divide in a 3? We cannot. Can we divide in a 4? Nope. Can we divide in a 5? Yes, we can. So negative 5 times what gets me to 35? It's a negative 7. When I add those together, do I get to this negative 12? Well, yes. Negative 5 plus negative 7 is negative 12. So that means this factors to be x minus 5, x minus 7. Okay, and both of these, we could check them to make sure it does work. We could FOIL them out to make sure we get back to the original. I just don't really have the room on this. Okay, so we've gone over 2 examples so far on this page where we have a positive and a positive. Okay, if you notice, we have the same sign, right? 2 positives, 2 negatives. Now here, I've got a negative 12. So I need it to multiply to a negative 12, which means I'm going to have different signs. And this needs to add up to a positive 4. Because this needs to add up to a positive 4, this is where my positive numbers need to be. This is where my negative needs to be. Okay? So, what are your multiples of 12? Well, always start with 1. So we've got -1, and a +12. When I add those together, do I get to that 4? No, we do not. So go to 2. Does 2 go in? Yes, it does. So -2 times 6 gives me -12. When I add, do I get to that +4? Yes, -2 plus 6 is a +4. So that means this factors to x minus 2 and then x plus 4. Okay, same thing here. I need something to multiply to this -42. But when I add, what's this coefficient here for my b? That's a -1. I need it to multiply. Nope. I need it to add to a -1. So this time, because my b is negative, I need all my negative numbers here and my positive numbers here. So let's start with 1 and 42. We have 1 and -42. When I add those together, do I get to my b? Nope, that's going to be -41. We're way off. So let's go down to 2. 2 goes in there. So 2 times -21. When I add those together, do I get -1? Nope, so keep going. We can divide in a 3. I think that's 14, but let's look. Okay, so 3 times -14 gets me to -42, but when I add, is that -1? Nope, that's -11, so we got to keep going. Can't divide in a 4, I don't think. Okay, can't divide in 4. I know I can't divide into 5 since it doesn't end in 0 or 5. But 6 we can divide in. So 6 times -7. When I add those together, do we get -1? Yes, we do. So now we get x plus 6 and x minus 7. Okay, and again, all of these we could FOIL, and all of these could be written backwards, right? Like this one could be x minus 7 and then x plus 6, so that doesn't matter there. And if we kind of look at the pattern here, a lot of people, especially with like these right here, where you do have to have different signs because my b is negative, means we need opposite signs, want to know which one's positive, which one's negative. If you're using this method where you're always going like 1, 2, 3, 4, 5, 6, and you're going through the order here, if this is positive here, you want this side to have your positive signs. If this side is negative, right, if you want it to multiply to a negative or add up to a negative number, then this side is negative. So you're always kind of going with what this one is here. This is a +4, you want that column to be positive. This is a -1, you want that side to be negative. And that does technically work here, right? It's a -12, you got all negative numbers. This is a +7, you got all positive numbers. But that one's not quite as bad because you've got positive, positive, and negative, negative. This one down here for C and D is when we have opposite numbers, right? Opposite signs, I mean. And so just kind of follow whatever your B is. If your B is positive, then that column is positive. If your B is negative, then that column is negative. Okay, so just kind of a little helpful hint there. Okay, last one we're going to do using this method here. And I have a typo, so it really doesn't matter what letter we have. I'm going to change this x to a b. So I mean, we got b squared plus 2p plus 10. You need those variables to be the same. Okay, so make your column. I need something to multiply to 10. Multiply to 10, but then add up to 2. Okay, and because this is positive, positive, it means all of these are going to be positive. So go through your list. You've got 1 times 10. When I add those together, do I get to 2? Nope, 1 plus 10 is 11. Let's go down to the next one. We can divide into 2. So 2 times 5 gives me 10. When I add those up, do we get to 2? Well, no. 2 plus 5 is 7. So go to the next one. We've got 3, but 3 doesn't go into 10. 4 doesn't go into 10. And then we've already got 5 wrote down. So these are all of my multiples of 10. Do I have anything that adds up to this 2? I don't. And when this happens, when you list out all your multiples and nothing adds up to your B, that means that this is a prime trinomial. Okay, and remember prime is like 17. To get to 17, it's just 1 times 17. To make it prime, you can only multiply itself in 1. Same thing here. To get to this right here, you can't multiply two binomials. Just b squared plus 2b plus 10 times 1 can get you there. So it is prime. It can't be broken down at all. Okay. So we went through those 5, and we went through a different method, right? We made a T-chart, listed out our multiples. I'm going to go back to what we did right here on example 1, making this x. It's a lot quicker. Okay, but one more time, if you're not good at your multiplication, this is not the method for you. So if you're not good at multiplication, you've got to keep making these charts to kind of walk yourself through what your multiples need to be. If you're good at your multiplication though, let's go to this x because you're going to see how much quicker it is. So in F here, we have y squared minus 17y plus 70. So when we make our x, my a times c goes in this top one. My a is 1. My c is 70. So we get 70. My b term is this 17, negative 17, so keep that sign with it, down here. And the reason I like to use that a times c instead of just calling it c, you'll sometimes get confused. Which one does this need to multiply to? Which one does it need to add to? If you can just remember, we're doing a times c, so it needs to multiply to here and add up to your b. So find two numbers that add up to negative 17, but when I multiply, we get to a positive 70. That is negative 10 and negative 7. Negative 10 times negative 7 is positive 70, negative times negative. But when I add them together, we get to that negative 17. So now, because this is a y here, we get y minus 10 and y minus 7. And you do want to be careful on MyMathLab, because if you type this in as x minus 10 and x minus 7, you factored right. You're just not using the variable that they use. So they're going to change that variable on you. So just be careful there. Okay, but as you can see, that went a lot faster, right? Now on G here, if you notice something, my squared terms over here, if they're out of order, you do want to kind of rewrite this. You always want your squared term first. So you've got r squared here. And then this is positive, so plus 5r, and then minus 14. So you want to kind of put that in order so you know your A, B, and your C. So now that it's in order, we can go directly into our x. So my A times C is 1 times negative 14. So negative 14 here. My B term is this 5. So find two numbers that when you multiply, give you negative 14, but when you add them together, you get a positive 5. And that is going to be 7 and negative 2. 7 times negative 2 gets you that negative 14. But when you add them, 7 minus 2 gets you that positive 5. If you switch that sign and you make that negative 7 and 2, when you multiply, you still get to negative 14. But then when you add, you don't get to that 5, you get a negative 5. So you do want to make sure that sign's with the correct number. So now that we have our two numbers, we're going to factor this to r plus 7 and r minus 2. Okay, h. This one is in the correct order. You've got your squared, your p, and then your constant, so let's go straight into that x. My A times C is 1 times negative 63. My B term is this middle one, which is a negative 2. So what adds up to negative 2, but multiplies to a negative 63? Because my B is negative, this is going to be negative 9 and a positive 7. Negative 9 times 7 is negative 63. Negative 9 plus 7 gets me to that negative 2. So now this factors to p minus 9 and p plus 7. And of course, all of these we could be foiling to check, and you can always switch the order of that binomial. Okay, on I, you got t squared plus 5t plus 1. So when we make our x, my A times C is 1 times 1. My B term is this 5. So what adds up to 5 but multiplies to 1? Well, your only multiples of 1 is 1 times 1. Is 1 times 1, or is 1 plus 1 5? No. So kind of like this one here, if you can't fill in numbers right here, then that makes this one prime. Okay, so that's an example of what prime looks like with both of those methods. J, we got b squared plus 5b plus 6. So my A times C is 1 times 6. My B term is this middle one here of 5. So what adds up to 5 but multiplies to 6? It's going to be 2 and 3. 2 times 3 gives me 6. 2 plus 3 gives me 5. So now we have b plus 2 and b plus 3. K, we have m squared plus 20m plus 100. So my A times C is 1 times 100. My B term is 20. So what adds up to 20 but multiplies to 100? That is 10 and 10. 10 times 10 is 100. 10 plus 10 is 20. So here we've got m plus 10 times m plus 10. Now when this happens, when your two binomials are the exact same thing, you do have to take this one more step further and put those together and make this an m plus 10 and then quantity squared. right? And we FOILed in that method before. When we were given a problem that had n plus 10 quantity squared, what did we have to do? We had to expand that before we FOILed. Okay, so if you have the same thing, you do have to condense that. And then last one on this page. This one's not in the correct order, right? So we want our squared term first. So we've got w squared. Now this one's negative, so we'll make this a minus 8w and then plus 16. So in my x here, my a times c is 1 times 16. My b term is negative 8. So what adds up to negative 8 but multiplies to a positive 16? It's going to be negative 4 and negative 4. Negative 4 times negative 4 is a positive 16. But negative 4 plus negative 4 is at negative 8. So because these are the same, if you want to go directly into like your condensed version, that's fine. But technically, we got w minus 4 times w minus 4. And since I can see it is the same thing, we got w minus 4 quantity squared as our final answer. Now, these do have a special name. These are called your, let's see if I can fit it here, your perfect square trinomials. Couldn't really fit that in, but perfect square trinomial. Okay, so you don't really have to memorize that exactly, but just so you guys know, when it does factor to the same thing and you condense it, those do have a special name since they are special types of your perfect square trinomials. Okay, so on this page in your Christmas colors, your green and your red, we went over one method of factoring, which is to make that chart. If you're not good at multiplication, that's the method you're using. And then in the purple and the blue, we went over the X method, which is quicker, but you do have to be good at multiplication. So you don't have to master both of these methods. You need to get good at one of them and then just stick with whatever method you're using. Okay. Now on the next page, we're going to be factoring more. If you like the Christmas colors, if you like the chart because you're not good at multiplication, you can use that. I'm just letting you know on that next page, I will be using the X method, okay? All right. And so here are, we kind of already went over that, but that is kind of a helpful thing for if you need to know what your signs are going to be. Now, objective 2 down here wants us to remember that the first step in factoring in a polynomial is to factor out the greatest common factor if there is one other than 1 or negative 1. First step, factor out GCF. So from now on, before we start factoring, we're looking for a GCF first. So on example 3, if you notice, these all have an A term, right? You've got 3, you've got 2, you've got 4, you've got 5. And I told you these would all look like this right here, right? With an x squared in the very front or a squared term without a number. So that lets me know right off the bat, I do have a GCF. So look at your 3 terms. What can you factor into a 3, a 24, and a 60? And that is going to be 3. Now, spoiler alert, this is always going to be the very first coefficient, so I can get that back to 1. Okay, just so you guys know. So, when I figure out that my GCF is 3, that 3 is going to come out here in parentheses. And now divide everything, every single term by 3. So here, 3 divided by 3, that cancels. And so we go back to x squared. That's the whole point. They should all end up there. Then you've got negative 24 divided by 3. It's going to give me negative 8, so negative 8x. And negative 60 divided by 3 is a negative 20. So if you're making a chart now, you're not using these numbers here. We're using our new numbers down here. So if you're making a chart, you would do negative 20, what multiplies to it, and then what adds up to a negative 8. So that's what your chart looks like. You're not using the 3, the negative 24, and negative 60. Okay, you're using this trinomial right here. But we're using an x. So with an x, now my a times c is the same thing. It's 1 times negative 20. My b term is this negative 8. So what adds up to negative 8 but multiplies to a negative 20, it's going to be negative 10 and 2. Negative 10 times 2 is negative 20. Negative 10 plus 2 gets me into negative 8. So now this factors to be x minus 10, x plus 2, and then remember to bring your GCF down of 3. So my final answer is 3 times x minus 10 and x plus 2. Okay, on B, look for a GCF first. Do I have a GCF? Can I divide anything into 4, 24, and 36? That's going to be 4, right? It's always going to be that first number. Okay, spoiler alert. So we have 4 on the outside. Now divide everything by 4. So 4g squared divided by 4. My 4's cancel. I'm left with g squared. Negative 24 divided by 4. It's going to give me a negative 6g. And then 36 divided by 4 is a positive 9. So if you're using your t-chart, that means you've got 9 and negative 6. What adds up, or sorry, what multiplies to 9, what adds up to 6. Okay, but I'm using that x. So my a times c is 1 times 9. My b term is this negative 6. So what adds up to negative 6 and multiplies to a positive 9? That's negative 3 and negative 3. Negative 3 times negative 3 is 9. Negative 3 plus negative 3 is a negative 6. So that means we've got 4 times g minus 3, g minus 3. Because it's the same, we're going to condense it to make this 4 times g minus 3 squared. Okay, and if you can see that because these are the same, that it's going to go ahead and go to condensed, you don't have to do that line there if you don't need it. Okay. Now, with A and B, notice we only have a GCF of a number. I couldn't take out an x in this one because this 60 has no x. I couldn't take out a g in this one because this last one had no g. But when you look, and this should be C, when you look at C and D, notice you have a K, and a K. You have a Y, and a Y. Because they all have a variable, we're going to have a GCF with a variable in it as well. So on C, look at your number first, then look at your variable. What can I divide into 2, 26, and 84? It's going to be 2, right? Always this first number so I can get it back to 1. And how many k's can I take out of a k squared, or sorry, k to the fourth, k cubed, and k squared? It's always the smallest exponent, so it's going to be this k squared. So I'm going to divide everything by a 2k squared. So here, let me move that down a little bit. Okay, when I divide this one by a 2k squared, my 2's cancel. And then k to the fourth divided by k squared. When you divide exponents, you subtract them. So 4 minus 2 gives me a k squared. The whole goal is to have a k squared there. Divide this one by a 2k squared. Negative 26 divided by 2 is negative 13. K cubed over k squared, subtract, that's going to leave me with 1k. And then divide this one by a 2k squared. 84 divided by 2 is 42. And then my k squared and k squared cancel, so we have no k left there. Now these are super easy to check. We could have done it on these two. If you distribute this back, do you get to your original? If you distribute this 3 back, do you get to the original? So it's not a bad idea to kind of mentally distribute that back to see if you get to everything. Okay, but now I've got my square term, my variable, and my constant here, and it's always in that form. So now, go into your x. My a times c is 1 times 42. My b term is this negative 13. So it adds up to negative 13 and multiplies to a positive 42. That's going to be negative 6 and negative 7. Negative times negative gets me to that positive 42, but negative 6 plus a negative 7 is negative 13. So bring down your GCF, and then this factors to k minus 6 and k minus 7. All right, and last one. We've got 5y to the 11th plus 10y to the 10th. This is supposed to be a minus 15y to the 9th. So look at your numbers. What can I divide into 5, 10, 15? And that is a 5. Oops, okay. And then how many y's can I take out of each term? You've got 11, you got 10, you got 9. A lot of times when we think greatest common factor, we think the biggest number, right? But this one here doesn't have 11 y's to give me, but they all have 9. So he's the smallest exponent. So now let's divide. So we've got 5y to the 11th divided by 5y to the 9th. My 5's cancel with each other, so I'm just left with y squared, 11 minus 9. 10y to the 10th divided by 5y to the 9th. Well, 10 divided by 5 is 2. 10 minus 9 is a 1y. And then negative 15, right? We scratch out that plus. Negative 15 divided by 5y to the 9th. 15 divided by 5 is 3. And my y to the 9ths cancel with each other, so you're just left with that plus 3. So now in our x here, my a times c is 1 times 3. Oops, and that's supposed to be a minus 3. Okay, right, negative 15 divided by a positive 5. Okay, so my a times c is 1 times negative 3. My b is that 2. So what adds up to 2 but multiplies to a negative 3? It's going to be 3 and a negative 1. 3 times negative 1 is negative 3. And 3 minus 1 is a positive 2. So bring down your GCF. and then this becomes y plus 3 and a y minus 1. Okay. Now that's really actually all of your lesson here. On this next page though, I made this last page one because I had an extra page. And this is to help you on your MyMathLab. Okay. So we've got some vocab at the very beginning. The first two aren't too bad. To factor x squared plus 7x plus 6, we look at two numbers whose product is 6 and whose sum is 7. Is that true or false? That is true because you want your product to be C and whose sum is your B. And so this one is true. On 2, we can write the factorization. Y plus 2, y plus 4 also is y plus 4, y plus 2. Hopefully that one is a no-brainer. That one is true. The order here doesn't matter with that. Now 3 is the main reason why I put these up here. The factorization of 4x minus 12 and x minus 5 is completely factored. We haven't really gone over anything like this because we don't really have these issues in this class with like this. But this one is false. And the reason this is false is if you look at this first binomial, you can take out a GCF. We have a GCF of 4. And so if you divide everything in here by 4, this would be 4 times x minus 3 and x plus 5. Now when you look at this, you can't take out a GCF here and you can't take out a GCF here. So now this is fully factored. Okay, and you don't have to actually fully factor it, but that's the difference because you can take out a GCF in one of those binomials that's not completely factored. It is factored, but not completely. Okay. And then on 7, as you guys have kind of realized by now, MyMathLab will take some problems and like walk you through the steps, and it's to try and help guide you, but it almost makes it more complicated. This is one of those problems. So this is number 7 in your homework from MyMathLab. We're told to factor x squared plus 14x plus 45. And so this is that one that's going to have like 8 different parts on it. So it says to determine the factors of the trinomial in the form of x squared plus bx plus c, find two numbers p and q such that their product is blank and their sum is blank. A lot of people go to this one here and they'll say that their product needs to be 45 and their sum needs to be 14, but that's not what it's looking for on this one. That's what it's wanting on this next part here. It's wanting you to use this generic trinomial and say that its product is C, but its sum is B, talking about B and C here. So you put in product is C and you put in the product is B, you hit enter, and now this problem pops up. And so now you can actually use the problem they give you and say whose product is, my C is 45, and whose sum is, my B is 14. So a lot of people will try and put that 45 and 14 in the first part. Once just C and B first. Then it says to complete the table. So how we made a table of saying like 45 and 14, and we put our multiples here, and we never really added, we just did it in our head. Now they're putting all of the multiples right here on one side, and it's just wanting you to add on the sum of the factors. So they did the first one for you. 1 plus 45 was 46. So now start adding. Negative 1 times negative 45 is negative 46. 3 and 15, add them together, we get 18. Negative 3 and negative 15 is negative 18. 5 plus 9 is 14. And negative 5 plus negative 9 is negative 14. So it says, because both 14 and 45 are positive, consider the blank factors of the table above. These are your two options. We want to consider only the positive factors. So then you get this portion here. Which pair of factors has the sum equal to the coefficient of the middle term? Well, the coefficient of the middle term is your 14. Which one here adds up to your 14? That's your 5 and 9. So you'll do 5, 9. And then it says the factorization of the trinomial in the form, blah, 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 blah. So anyways, factor completely. So now we can finally say x plus 5 and x plus 9. Okay, so that's what it's sort of looking for on this one. So I just wanted to kind of show you that so you don't miss this very beginning one and then you have to redo it all because you missed the beginning because you don't know what it's asking because it's making it complicated. Okay, so that is our lesson over factoring trinomials 13.2. As always, pause this video and rewind it as much as you need to and let me know if you guys have any questions.